Assalamualaikum and hi. So, today my friends and I will introduce to you about acid and alkali. So, before we go through to the topic, let me introduce you to my friends members. So, the first one is Nur Safiya Binti Razman. The second one is Nur Mohamad Nur Hariz bin Mohamad Nasri, which is me. The third one is Siti Hajar Nabiha Binti dzulkarnain. And the last one is Nur Amalina Binti Mohd Saifullah. So as you can see, we will introduce to you about the acid and alkali. So without wasting so many times in here, so let's get through to the topic. Before we go through to the topic that will be explained next, so let's take a look with the agenda that will be covered on this topic. The first one is the meaning of acid, alkali, and their application. And the second is the strength of acid and alkali. The third one is the pH value. The first one is basicity of acid, and the last one is neutralization. So let's get through to the meaning of acid and alkali and their application. Okay, so for the first topic, which is acid and alkali, will be introduced by Nur Safiya Amira Binti Razman. Let's take a look.
So, what is acid? When acid is dissolved in water, the hydrogen atom in the acid molecule will release in the form of hydrogen ion. To conclude, acid is chemical substance that ionize in water to produce hydrogen ion. There are two types of base, which is soluble and insoluble. For base that is insoluble, it will react with acid and will produce salt and water only. For base that is soluble in water, it will produce hydroxide ion, which is it is called as alkali. So to conclude, alkali is chemical substance that is ionized in water to produce hydroxide ion. So now let's talk about the application of acid and alkali. Alkali is used in toothpaste because when we eat, the acidity in our mouth is increasing. By having alkali in the toothpaste, it will neutralize the acidity in our mouth. Next, we have acid. Acid is used as a preservative because it can stop bacterial growth.
Okay, so next we will go to the topic number 2, which is strength of acid and alkali. And this topic will be covered by Siti Hajar Nabiha Binti Zulkarnain. Let's take a look.
Now let's talk about the strength of acid and alkali. We can identify the strong in weak acids by the way it ionizes in water and the concentration of hydrogen ions H+ that is produced. A strong acid is an acid that ionizes completely in water and produces a high concentration of hydrogen ions H+. Hydrogen chloride is a good example of strong acids because all molecules of hydrogen chloride that dissolve in water are ionized completely to hydrogen ions H+ and chloride ions Cl-. No molecules of hydrogen chloride exist anymore in this solution. A weak acid is an acid that ionizes partially in water and produces a low concentration of hydrogen ions H+. Ethanoic acid CH3COOH is an example of weak acid. Acid has 1.54% of degree of dissociation. In other words, out of 100 molecules of ethanoic acid, only one that ionizes to hydrogen ions H+ and ethanoic ions CH3COO-. A strong alkali is an alkali that ionizes completely in water to produce a high concentration of hydroxide ions OH+. Sodium hydroxide NaOH is a strong alkali as it undergoes complete dissociation when dissolved in water. A weak alkali is an alkali that ionizes partially in water to produce a low concentration of hydroxide ions OH-. Ammonia solution in H3 is an example of weak alkali as it has the degree of dissociation of 1.3%.
Okay, now we will see the third topics in this presentation, which is pH value. This topic will be covered by Nur Amalina Binti Mohamad Saifullah. So let's take a look together.
Okay, first let us go through to the definition of pH. In chemistry, pH means a logarithmic measure of the concentration of hydrogen ions in an aqueous solution. pH scale, which ranges from 0 to 14, will show an acidity or alkalinity in the aqueous solution. And as we all know, solution with pH value less than 7 is an acidic. Meanwhile, solution with pH value more than 7 is an alkaline. There's many ways to determine pH value, such as using universal indicator, pH meter, or pH paper. We also can determine pH value by using calculation. For example, if we want to determine pH value of an acid, we can use this formula, where log is logarithm base 10 and the H plus symbol is concentration of hydrogen ions in mole dm cube of the solution. Other things we need to remember for acid solution is the higher concentration of hydrogen ions, the lower pH value of the acid solution will be, which means acidity increases when the pH value of the solution decreases. Next, if we want to determine pH value of an alkaline, we can use the same formula by changing the concentration of hydrogen ions to concentration of hydroxide ions and adding 14 to the front, which represent highest number in the pH scale. And for alkali solution, the higher concentration of hydroxide ion, the higher pH value of the solution will be, which means alkalinity increases when the pH value of the alkali solution increases.
So next, we will go through the topic 4 in this presentation, which is a basicity of acid. So this topic will be covered by me. So let's take a look together. Okay, firstly, what is basicity of acid? Let me introduce to the meaning for you. Basically, basicity of acid refers to the number of replaceable hydrogen ions protons that can be donated by a molecule of that acid in a chemical reaction, and also known as a measure of the capacity of an acid to donate protons. Now, we will take a look at three common types of basicity of an acid. So, firstly, we have a monobasic, which is one molecule produce one H plus ion dissociation. For the example, we can see the HCl and HNO3. The dissociation equation we can see at the bottom. Next is dibasic. We can take a look at the definition for dibasic, which is one molecule produce two H plus ion upon dissociation. Um, and for example, for dibasic, we can see that here we have a H2SO4, and at the bottom we can see the dissociation equation. And the third one is a tribasic. And the tribasic definition is one molecule produce three H plus ion upon association. And we can take a look at the example for tribasic, which is a H3PO4. And at the bottom we can see the dissociation equation. Next, we will take a look how to find the basicity of acid. Let's take a look together about how to find the basicity of an acid. I have found one example for you, which is a HCl. So firstly, HCl is split into H plus Cl minus. Secondly, is in the aqueous medium. We can take a look the equation at the bottom. So here, hydronium ions can also be referred as the H plus ions because they can break into water and H plus ions. As you can see for the equations at the bottom at the bottom of the word. Here, the number of hydrogens, hydronium H3O plus ions produced equals 1. Therefore, it can be said that the basicity of HCl is equal to 1. Now, we have arrived to the last topic in this presentation, which is neutralization. So, before wasting for many times, let's take a look together. So, what is neutralization? Basically, neutralization it is an acid-base reaction in which an acid reacts with a base to form salt and water. Um, the pH of the neutralized solution depends upon the acid strength of the reactants and their concentrations. As you can see here, we have an example of neutralization. Now we will take a look about neutralization reaction. When a strong acid reacts with a strong base, the resultant salt is neither acidic and nor basic in nature, which is it is neutral. For example, we can see HCl hydrochloric acid, a strong acid reacts with now a strong base. The resulting salt is sodium chloride and water, and you can see the equation at the bottom. Next, when a strong acid reacts with a weak base, the resultant salt is acidic in nature. For example, FeNO3 is an acidic salt formed due to the neutralization of iron hydroxide, a weak base with nitric acid, a strong acid. We can see the equation at the bottom. Next, likewise, when a strong base reacts with a weak acid, then the resultant salt is basic in nature. For example, K2CO3 is formed due to the acid-base reaction of potassium hydroxide is a strong base and H2CO3 a weak acid. We can see the equation at the bottom. Okay, now here we have a strong acid and a strong base example. So for strong acids, here we have HCl, HBr, HL, HClO4, HNO3. For the strong bases, we have the example of CaOH2, SrOH2, BaOH2, LiOH, NaOH, KOH, RbOH, and CSOH. Lastly, we will take a look at the application of neutralization. This method is used in the wastewater treatment in order to reduce the damage created by the effluents. Neutralization is used in the manufacturing of anti antacid tablets. The neutralization reaction is used to control the pH of the soil. I think that's all from us. Thank you very much for watching and see you next time.